Hello YouTube and welcome back to another video. Today we'll be working on solving some problems with inverse functions and graphing inverse functions. So let's start. For question 1, it says for each question determine its inverse. So we have the function f of x equal to 2x plus 3. So our first step, what we're going to do is we're going to just write the equation in terms of y. Get rid of this f of x. That can be confusing. So we can say y is equal to 2x plus 3. We haven't really changed the function at all. All we did was replace the f of x with a y, which is basically just saying the same thing. So next step is what we have to do is exchange the y's, exchange the x and y, swap them in places. So let me do this in a different color. So what we're going to do is we're going to swap these two. So then we're going to be left with x is equal to 2y plus 3. And lastly, all we have to do is solve for y right here. So let's quickly do that. So we can subtract 3 from both sides. We're left with x minus 3 is equal to 2y. And we can say divide by 2. So we can say y is equal to x minus 3 divided by 2. There we go. There is our inverse function for there. So we can even write this in more specific terms. You can say f inverse of x is equal to x minus 3 all over 2. So there we go. That is that. Let's move on to the next question. It's a different color here. So we're given the function h of x equal to 1 over x plus 2. So again, I want to write this in terms of y. It isn't really changing anything. Just makes our life a lot easier. So we can say x plus 2, 1 over x plus 2. This is saying the exact same thing. Next step is replace the x and y. So we're talking about these two things right here. So just swap those in place. So we're left with x is equal to 1 over y plus 2. And let's keep going. Solve for y now. So we multiply both sides by y plus 2 to get rid of the denominator. So we can say multiply by y plus 2. Multiply this by y plus 2. And once we simplify, we're left with, distribute the x, we're left with xy plus 2x is equal to 1. There we go. So now all we have to do is solve for y. So we can subtract 2x from both sides. We're left with xy is equal to 1 minus 2x. And all we have to do now is divide both sides by x. So we're left with, let me go all the way up here to give myself more space. Whoops. Let's go here. We're left with divide both sides by x. So with y is equal to 1 minus 2x all over x. And this can be simplified down by breaking up the fractions. So we can say y is equal to 1 over x minus 2x over x. These two will cancel out. So we're left with, quickly change the color, y is equal to 1 over x minus 2. And we can write this in more specific terms. Let's say h inverse of x is equal to 1 over x minus 2. And there we go. Let's move on to our last problem here. So we're given the function g of x equal to cube root of x plus 4 minus 2. So again, what we're going to do is we're going to replace the g of x with y and write the whole thing over again. So we're left with the cube root. That's one big square root, but we're going to work with it. Sorry, cube root. Minus 2. There we go. And we're just going to swap these two over here. Swap the x and y. Oops, not the y and 4, the y and x. There we go. And we're going to get x is equal to the cube root of y plus 4 minus 2. Minus 2, sorry. And all we have to do is solve for y now. So we're going to add 2 to both sides. So we're left with x plus 2 is equal to the cube root of y plus 4. And we're going to take so we're going to cube each side. So we're going to do this cube it to get rid of this thing right here. So that's going to cancel out. And we're also going to cube the left side here. And we are left with x plus 2 cubed is equal to y plus 4. And all you have to do is subtract 4 from both sides, and we're left with y is equal to x plus 2 cubed minus 4. And there we go. I think we're done. And just to be more specific, we can write in terms of g of x. So we're going to have g inverse of x is equal to x plus 2 cubed minus 4. Okay, there we go. Let us move on now. So for the last question here, let's start working on it. Let's use the color, let's say green. Green seems like a nice color. So it asks for the given function, graph its inverse. Okay, so if you guys remember from the inverse functions video, all we have to do is flip the x and y coordinates to graph our inverse function. So to start off, let's just pick the point 2, 0. So it's at 2, 0. Now, instead of being at 2, 0, it's going to be at 0, 2. Because all we did was flip the x and y, so it goes from 2, 0. And then these two are flipped. Now it's going to go from 0, 2. That's basically all we're doing for each individual point. So let's choose some more points here. I'm noticing at the point, this is at 3, 1. So instead of being at 3, 1, it's going to be at 1, 3. So it's going to be right over there. And now let's keep going. This is at the point 4, 8. Clearly they've labeled for us, which is nice. So instead of being at 4, 8, it's going to be at 8, 4. So that's going to be at 5, 6, 7, 8, and 8, 4. There we go. And we could keep going, but the graph, it doesn't seem like there's any identifiable points visible, so let's just stop there for now. Let's go into the negatives now, so instead of it being at, yeah. So I'm noticing another point here is at 1 and negative 1. So right there, so instead of being at 1, negative 1, it's now going to go to negative 1, 1, right? Because this point was at 1, negative 1. It's going to go to negative 1, 1. There we go. And let's check out where the y value for 0 is. We're going to check out, it looks like this is at 5, 6, 7, 8. So it looks like it's at 0, negative 8. This is going to go to negative 8, comma 0. But it seems like we can't graph it because this only goes up to 5. So it'd be somewhere, let's just pretend this is at negative 8. So it'd be somewhere right there. So let's start beginning to graph this. So it's going to look something like this. Right there. And there's our x coordinates. And we could go even higher, like right. Whoops, it's too steep. Let's go gradually in. And there we go. This would extend both ways. And there you have it. We just graphed the inverse.